Okay, thanks for coming. A little bit of polling or letting to know a little bit about the audience. Who's using containers in production? Please raise hands. Oh, quite a few people. How many is using Kubernetes? What's the other people using? DCOS Mesos? Any hands? Docker Swarm? Rancher-S? Plain Docker? Okay, cool. So the idea today is share a little bit of our experience monitoring microservices and monitoring containers. I work for SysDig. We do container monitoring. I'll let you know a little bit about that later. But I would like to start with this example. There is like some kind of general assumption that when you need to set up a monitoring tool, you just get your apps metrics, custom metrics, JMX, infrastructure metrics, whatever it is. You put all those through some kind of washing machine, some processing, whatever, and then suddenly you get like unicorns and rainbows and those fancy dashboards that you can put on a TV in the office, and they look awesome. But in reality, is that that thing doesn't really work, at least always. And even if you're a vegetarian, unicorn meat is not very interesting. A little bit about myself. As I said, my name is Jorge. I've been working on open source for a few years. Also, I've been working in the monitoring ecosystem for some years. And at the moment, I work at SysDig. I consider myself a containers gamer because I have the privilege to spend a lot of time playing with different technologies, learning new things, and then sharing my learnings with other people inside and outside of the company. Just if you have any feedback, comments, complaints, or just bullshit, just tweet me. A little bit about the agenda. Today we learn about the challenges of monitoring container infrastructures, the problems or the limitations of traditional monitoring tools. I'm not going to mention any of them. Today it's being recorded, but you can imagine. Best practices, or what we have learned with our customers, and I will show you a little bit about SysDig, both the open source and our monitoring tool, both of them. So let's start from the beginning. We think that microservices and containers break any traditional monitoring model that you might have implemented. How to explain that? Well, let's look at how we used to deploy our infrastructure. A few years ago, we had our sysadmins rather than ops people. And when they had to deploy new applications, they had to call the hardware provider, get new server, install the application or the operating system. Well, I realized I put systemd there, but we didn't have systemd then. So yeah, it's still a bunch of basic services, and then developers, they were asking for different applications or services that they require, like MySQL, Java, different Java versions, OpenSSL. They had to upgrade OpenSSL because it was vulnerable. So it was this kind of nightmare, and then the developers, they were coming, installing their code in the servers, using FTP or even worse. And well, that was how people they used to deploy software in their infrastructure. If we look at how software works, it hasn't really changed for a very long time. Every software, it's going to be exactly like this. We have a backend where we store information, data. We have some software in the middle that does some kind of transformation, and then a front end, either a UI or an API, or somehow we expose to a consumer that information. But at the moment, we are in the middle of something that we could call the Docker revolution. How we have arrived here. As I was showing before, at the beginning, or at least a few years ago, the unit, when working on infrastructure, it was the server. If we had to install a new application, first thing to do, it was get a server. There was no kind of orchestration. Sysadmins had to get the CD, install the operating system, SSH in the best case scenario, install things, and applications, they were monolithic. When you had to deploy your database, it was deployed on one server, or maybe in a cluster of servers. But things, they were not moving much around that. Virtual machines, they came, they were awesome. We could consolidate more applications in the same software. Still, when we had to run a new application, we had to create either a virtual machine, or if we were full or fully booked, we had to buy new hardware. We started to have some kind of orchestration attached to this new model, as people could template virtual machines. But still, how applications they were being deployed didn't change much, because when we had to install a server, a database, whatever it was everything running in the same VM, didn't change. Containers, microservices came, and suddenly everything has changed. Not only how we design the applications, also how we manage the infrastructure behind. So now the unit, it's a microservice. When we need to implement a new application, you don't think, oh, I need a server or I need a VM. You think, oh, I need a database. I don't really care where is that happening. Maybe the policy of my company will have some limitation or restrictions, but I need a database, or I need some kind of something where I can run that service that I need. Looking at that, we have orchestration already included in this kind of infrastructure, either because if it is managed and we don't need to handle that, or because we are using Kubernetes, Rancher-S, Swarm, or Docker Compose, whatever it is, we have some kind of orchestration already included. Also, how the applications are being designed has completely changed. We are not looking at monolithic applications anymore. We are looking at microservices where the applications, they are, in theory, at least fully distributed. So, going back, we have something like this, where the operations team deploy some servers with operating systems, and they offer that as a platform to the rest of the company or the organization. The developers, they choose the services that they need for their applications, and they deploy, and everything looks and works better. But in reality, what's happening under the hood is that we have a bunch of different servers with different containers running different microservices that they are moving around across our infrastructure, and we don't have that clear picture that we had before where everything was sitting in the same place. We have a lot of components, pieces moving around, and actually they are talking to each other. So we have highly increased the complexity of our infrastructure. Still, looking again at the application level, it's again the same. We have the backend, the middleware, the front end. It's just that now every service has been decomposed in different microservices or different containers that they are running in different places. So we think, or we see that some things are changing, some things they are still the same, but we see a lot of changes. And actually, talking about changes, another thing that we should mention is how people are getting organized in different organizations. We see more and more companies where the developers, they have the responsibility of running and maintaining the services that they need for their applications. Or we have scenarios where we need multi-tenancy because I'm a consultancy company and I have multiple customers running in the same platform, and they have different privileges or levels of visibility. So that's also changing, not only the infrastructure, but how people are working. That's basically presenting us a number of different challenges, and we are going to go through these 4 of them. How we get metrics in microservices. How do we get metrics in containers, inside containers? Second, how we do make sense of all that amount of information. Before we had a bunch of servers, now we have hundreds of containers. How we do analysis and troubleshooting. And finally, how Teams is changing. So let's start from the beginning. We all love containers because multiple reasons, but probably because they are simple, they are small, in theory, they are isolated. Everything that's contained in the container should stay there. And they have less dependencies, at least also in theory. You just bundle the libraries that you need for the service or the process or the software running inside. But so it's awesome, it's great from a developer perspective. In some cases, it's also great from an operations perspective. But when we need to run this in production, we need to monitor, we need to maintain, they are basically a black box because tools, monitoring tools, troubleshooting tools, any kind of sysadmin or operations tools, they don't have much visibility of what's happening inside. So people, they started to apply workarounds. So before, when you had to monitor a server, what you used to do is to get your monitoring tool of choice, install typically an agent. So why now we cannot do the same? We get a container, so we install our software, our application inside the container, and we install the agent. That basically breaks a bunch of Docker principles. So it's not simple anymore. We have 2 applications. We have more dependencies, a bunch of libraries that we shouldn't need, and it's breaking the principle of one container, one process. Actually, in addition, there are double of things. So for every process, we have a monitoring agent, so twice things that it can break. Some people, they thought, okay, we can fix some of these issues. So in Kubernetes, there is this concept of pods, where 2 containers, they share some things in common, for example, network namespaces and a bunch of other different things. So what if we put for each of my applications or microservices container an agent or an exporter, something like that? Okay, so I'm not breaking those Docker principles, but my problem is that still I have that problem of complexity in instrumentation and double things that can break. Third iteration, some people thought, okay, so what if Docker exposed some metrics through the Docker API? I could collect those metrics from an agent installed in each of my computing nodes, and I could export those metrics into my monitoring system. I'm solving the problem of not going along with the Docker principles, and I'm solving the problem of complex instrumentation. But there are still some limitations. We can only see whatever Docker API exposes to us. Still, we need to instrument every time a new container is created or destroyed. And we are talking about very dynamic infrastructures. So we solved some problems, not all of them. So we thought, why don't we do something completely different? And I'm going to talk about the technology we created at SESEC. Basically, we have taken a very different approach. We sit at the kernel level. We get a very small kernel module that captures all the system calls. And from the system calls, we can have full visibility of everything happening on every computing node. The idea is because how containers work, they share the kernel with the host, so we can see everything. There is no need to instrument new containers or containers being destroyed, or we can see the processes running inside of each of the containers and all the metrics. So basically, because we have quite a technical audience today, I put some extra details. It doesn't really matter if the application is running directly on the host or inside any of the container technologies, Docker, Rocket, LXC, whatever it is. Basically, we capture every system call, we copy them into a shared ring buffer, and then from user space, asynchronously, we will start picking up all those system calls, dumping them into a file, doing some analysis, whatever we want. At the end, our user space process sees an event stream with all the system calls and some extra information attached, like process, parent process, network IP addresses, so on and so on. So we think this is awesome, this is cool, for a number of reasons. We just need to do one instrumentation for every host. If you create, or your container orchestration platform creates new containers, it's completely transparent to us, we will see everything. But in addition, and this is something unique to this approach, is that unless Docker container or Docker API-based monitoring tools, we have full visibility. We can do a bunch of cool things like automatic service discovery. If you run a container that has a process called MySQL running inside, we can automatically detect that we should be running a MySQL check against that container. Or we should automatically do things like looking at the application layer monitoring, for example, decoding the traffic in those file descriptors, in those sockets, and we can automatically see MySQL queries. And that's some kind of visibility that otherwise you would need called instrumentation. We just do it automatically. If you have a Java web service, and automatically we can see service response time, we can see most used or most accessed HTTP URLs or slowest URLs, just decoding the HTTP traffic in those sockets without doing any kind of instrumentation. And I don't really care if it's a Java web service, Nginx, Apache, whatever it is, because automatically I can have full visibility of everything. This is like just quick animated screenshot of the UI, and can show you the product later. So we have kind of solved the first problem. How do we get metrics? How do we shape all that amount of information? Remember, before we have 6 servers with the applications. Now we still have 6 servers, but we have a big number of containers running on each of your servers. So you have plus 100 times probably the number of metrics that you had before. So how do we make sense of all that information, of all that, of those metrics? We think that infrastructure monitoring should be completely transparent. Come on, there is millions of people running infrastructures out there. Why you should be doing this work again of configuring, deploying, learning how to monitor your infrastructure? That should be part of a tool or of a product. You should just care about your KPIs, about the metrics of the business metrics of your applications, basically what you are working on. Everybody or should be standard how to monitor a MySQL database, an Nginx web server, whatever it is. In addition, all the metrics, they should be tagged. So we know that these metrics, they are coming from this container, that container it belongs to this service that is in this part of my infrastructure. And who is the piece of software that has all that knowledge, that knows how many services you have, how many replicas for each service do you have in your infrastructure, how many nodes, which containers are running each of those nodes. It's going to be your container orchestration platform, Kubernetes, Mesos, Rancher, Swarm, whatever it is. So what if the monitoring tool could talk to your container orchestration platform and get all that information automatically? That way, you just focus on your application metrics and your KPIs. At the end, because if we look from a physical perspective, what we are going to see is something like this. In our company, there are a lot of Italian people, and they call this the spaghetti dish, because you see, like, all the containers are running in all the hosts, moving around, the different communications between them. It's kind of a nightmare, because what we want to see is something like this. This is a topology map of a production environment in a Kubernetes cluster, and I can see a consumer talking to another service, which is WordPress, that's talking to my SQL, and then a Java client talking to my Java app that talks to 3 different databases, and I can see how the connections, they flow between the different services. And actually, if I could zoom in the different entities and see how many replica sets or instances I have for each service, and how many containers I have inside of those, and what are the processes inside of those containers, because I can get that information. That would be awesome. Well, this is kind of some of the features that Sesde can do. I can show you afterwards. At the end, you need to remember that whatever it is, the container orchestration platform you use, just get your monitoring tool, talk to them, because they have a lot of information. I'm going to talk a little bit about Kubernetes specifically. When deploying Kubernetes, we should think that there are new layers that we need to monitor. There are new things, new parts that we didn't have before. Another thing to consider is that services, containers, they are not coupled with servers, with physical nodes anymore. So the number of instances of a specific service can change. You can have 3 front-end servers, but then if you have a peak of traffic, Kubernetes can decide to automatically scale that up, and that can be fine. And then if you have less traffic, those containers, they can be, or that service can be scaled down. You will have less number of containers, and that can be completely fine. Something expected that should never wake you up from bed. killing a process on killing a container can be completely fine. It's Kubernetes job, so we shouldn't worry about that. So we change not only the alert, but how we are getting all that information. We need to understand what's Kubernetes thinking about, what's the situation. We need to know how many pods Kubernetes is running, how many pods Kubernetes wants to have running, because those are different metrics. And tagging everything, it's very cool, but actually if we can do some things like auto-discovery, it's way better, because obviously if we need to configure things, we will forget. When I'm looking at implementing monitoring at a Kubernetes cluster, there are at least 5 layers that you should look at. The application layer, this is not new. You should be doing this before, looking at how many, how many transactions I had in my shop. Those KPIs of your application. At the service level, so if I'm using this middleware or this application, this database, this web frontend, the metrics of those services. But now there are a few things new, like Kubernetes deployments. If we are deploying software, the deployment might break, so we need to look, okay, so has Kubernetes deployed the new containers as I instrumented? Or if I'm in the middle of a rolling deployment, I might have for some time less containers than desired because things they are crossing. That might be fine, but not in the long term or even medium term. So something that needs to finish that rolling deployment. So we need to monitor if Kubernetes is basically doing its job. Additionally, we need to monitor Kubernetes itself. It's composed by a number of different services, API server, kubelet, all those services, we need to make sure they are running, otherwise Kubernetes is going to fail. Last thing, or last layer, we need to monitor still nodes hosts. It's important. Obviously, if a host fails, it's Kubernetes' job to schedule those containers that they were running there into a different host. So again, this should be something that we should leave to the next morning, shouldn't wake us from bed. But if a node is, for example, on full disk usage, it's something that we want to have a look. Still, we need to get alert. So we need to have still some monitoring there. So we have seen how to get the metrics, how to make sense using Kubernetes metadata and tags on all those metrics. Let's look at how we can do troubleshooting. And I'm going to use a real example for that. This is an issue on Kubernetes GitHub project where some user is asking for a problem. You can check it out, the whole story. And one of the Kubernetes members is recommending, well, there are not really good troubleshooting tools for containers to Docker run bash, some sleep, some prints, echoes, whatever, and just pray for this to work. Think, what if we have tools that they understood how containers work, how namespaces work, cgroups, how those orchestration platforms create the containers. Imagine all those tools that you used to use some years ago for Linux troubleshooting, strace, Wireshark, htop, LSOF, IOSAT, all those tools that they are not really useful anymore because they don't understand namespaces. Imagine if all that tool set was ready for containers. They understood namespaces. Imagine that you not only have the metrics, but all the activity that's happening inside the containers, access to file descriptors, sockets, file system network, everything. And what if we could dump all that information into a file for offline processing and analysis? Because containers, when you have a broken container, it starts, it crashes, it dies, it's not available anymore. We cannot SSH inside, we cannot do Docker exec bash because the container is gone because the process has crashed. So we need different ways. So that's why we created Cyclic Open Source, which is a tool like this. We have two interfaces, one purely CLI, like similar to TCP dump, but for your entire system, and another with Courses UI If you have used HTOP before, you will see it's very similar. If we have time, I'll do a live demo afterwards. The idea is that you can see all your containers, the processes running inside. In this case, for example, we can see the containers from or using the Kubernetes metadata. So we have all that information together in one tool. We can look at the file descriptors, all the system calls, etc. We'll have a look at that. And last point, teams. And for this, I'm going to use an example. One of my friends, Francesc, he works at the Spotify. And a couple of months ago, he was explaining how they have changed on-call in Spotify. I'm not saying that everyone should be doing this. It just helps me to illustrate this trend that we see of more companies giving more power to the developers. I'm not going to discuss if that's a good or a bad idea. I'm just saying it's happening. The idea is that developers, they need to handle those databases, those brokers, message brokers, middlewares, whatever they need for their code. And the operation teams just operates the platform where everything is running. So we end up into a situation when we have database team or even Cassandra team or different customers. We need different levels of visibility in our monitoring tools because we are not going to give all the people visibility across the infrastructure because they have different levels of access. Who has information on what are the components in my infrastructure? It's going to be, again, my orchestration tool. Namespaces, deployment, services, even we can add custom tagging inside tools like Kubernetes. What if we could take all those entities, apply some ACLs, some permissions, and use those to define visibility and access for the different teams? In addition, what if we could apply default dashboards or default alerts to all those services because we know how to monitor them? So if a team want to run a MySQL service, automatically they could get the right MySQL dashboards and the right MySQL alerts following the policy that the operations team has defined. So that's one of the other things we have worked at Testic. There's some work in other open source tool. In number 2, we are basically leaders or the first ones to implement some of the things we have seen in points 1, 3, and 4. We have 2 different tools. I have shown you Sysdig. It's 100% open source. We have plenty of downloads from our website, but it's also available in Docker Hub as a container and in all Linux distributions. We don't really know how many people are using it, a lot of them. That tool, it's mostly designed for host analysis and troubleshooting, making sure that we're finding out what's happening to those containers running on a specific host. That was very successful. A lot of people like it. So we decided to create a company and a commercial tool based on the same technology. And that's why we built Sysdig Monitor. It's available as a service, SaaS, and also an on-prem software that you can deploy on top of your Openshift or Kubernetes. We have quite a few customers. We work at the cluster level, so we collect metrics from their entire cluster, working with all those orchestration tools we had before. And it is a full monitoring tool, not only troubleshooting, but it includes dashboards, alerts, events, teams, all those things we have seen before. Just check it out. I'm showing a bunch of customers. This is in Spanish. So in addition to all these 2 different tools, we also have 2 small pet projects that I would like you to have a look if you like all this. One is Sysdig Tracers that allows to annotate your code we do kind of a small hack right into /dev/null. So you can tag when the different pieces of your code is being executed, and you can monitor latency inside your code. It's some kind of traditional APM, but very, very lightweight. And you can use it in Bash, for example. You can do all sorts of hacks. And Sysdig Falco, which is a security product or security project built, again, the same technology. As we can see everything, all the system calls for all the different containers. We can define profiles or security profiles of what they are doing, and we can alert if things they are behaving in a different way as they should. So if a Cassandra server is doing an outgoing connection to an external IP address outside of our infrastructure, probably we have been hacked. So we can create alerts based on that behavior. So thanks for listening. I don't know how much time I have left. Yes, we have 5-10 minutes more. So questions, and probably at the same time, I can show you a little bit about the product. Yeah, over there.
Yeah, so thank you very much for the presentation. Was very interesting.
Thank you.
Some stuff really hit on. I actually do have a question regarding use case where you are using, for example, Kubernetes as a service. In that case, if you don't have access to the kernel, how do you actually monitor those system calls?
We always need to have access to the kernel. The agent runs inside a privileged container. We have built kernel module binary files for the official kernels. And if we don't find a matching version, we automatically build one using DKMS. And we inject it outside the kernel. So it's built inside our kernel, and then we use insmod to inject it outside.
Right, so you actually need to own the platform from the point of view, right?
Yes, but if your question is, does this work in, for example, Google Container Engine? The answer is yes.
Okay.
Actually, it works, for example, in ECS as well. So, or Docker for AWS. Works because even if you don't own the image, you can do a bunch of things and insert the kernel module. More questions?
Are there issues using just the? I mean, you're gathering all these systrays, so
yeah. I guess. So actually, that's a question that I get quite often, and I have a very good answer for that. Actually, you can use Sysdig to look at the performance impact of the agent. So if we come here and we search for Sysdig, and I have the right grouping, no, return is not there. Let me do this. I can go. I have not prepared the answer before. So here we have all the Sysdig agents. It's going to be one of these. I'm not having the right segment. Anyway, so each of these are my Sysdig agents. So when I come here and I can do an overview by process of this container, I can see that is using, actually, I can confirm the processes. I can see the Sysdig agent processes running here. So if I apply one of these views, I can see that this specific container is using 1% of CPU, 6% memory, and this amount of traffic. I can get the graphs in here. As you can see, it's pretty low.
That's user space.
Yes.
So that's the agent, not the kernel module.
Yeah, the kernel module doesn't have any impact because it's basically copying in memory. Yeah, it just copied the system calls to another region in memory. Actually, we do a very cool thing, which is we sample every second. And then we move that into the user space. And we group those samples in 10-second samples, and they are sent into the backend. If at any moment we start seeing more than 5% CPU usage, what we do is automatically we start downsampling. And instead of sampling every second, we start every 2 seconds, every 3 seconds. At the moment that we have available resources back into that node, we start collecting more frequently. So this is dynamic. You can also configure it manually. At the kernel level, it doesn't have any real impact because the high processing, it's happening at the user space. The user space is where we see all the system calls. We need to go through all of them. We need to identify which ones they belong to the service that we are monitoring. So we are dropping the rest. We need to decode the application protocol. So that's quite resource intensive. No, that's our job. That's why you are paying. At the end, it's like the magic is being able to do things like this. Let me apply this filtering. So I have my swarm cluster, and I come here, and I want to give me service overview. Where's service overview? So now this is service topology. Where is this? Where is this? Overview. Service overview. So automatically I can see on my services, containers, request counts, everything, or overview by service. So I can see how many container images I have for each of my services, request time, CPU by image. So I can see Postgres is taken out of CPU. Or I can go to look at application layer metrics. I can go, for example, into this Java application, apply an HTTP view, and get information like which are the top URLs, slowest URLs, or what's the request time information that otherwise I would have to instrument my code. Or can go to this MariaDB application, apply MySQL view, and get, I need to zoom in, and get all the MySQL requests of a WordPress application against just decoding. The nice thing is I'm doing this on the MariaDB container, but I can go to the WordPress container, apply the same view, and I will get the same metrics because PHP is writing those SQL queries into the socket that talks to MariaDB. So it's a cool hack. A lot of visibility, very little price.
How do you offer information to the operating system?
Say that again, sorry?
How do you offer that information to the operating system? How is it accessed? The point is, if I'm a bad guy and decide we can expose in order to perform an attack, or just really attack, just getting some information or passwords maybe, or whatever.
Yes, actually.
So how is that exposed?
That's why we implemented teams. So, for example, no, just the people who has access to the database should be able to see these kind of metrics.
Low level, just to the kernel module.
Oh, the kernel module can see everything because can see all the file.
How do you expose that information to the OS?
Oh, we copy all the system calls into that share buffer with the user space tool that can read. That process is root. It's root and can read that buffer. So if you are root anyway in your host, you can see everything in any way. The tool has been certified, for example, by Red Hat. So, for example, if you are running Red Hat Enterprise or any of those licenses, they analyze the source code. Also, it's open source, so you can have a look. And you can see just it works. Actually, we haven't changed it in some time because it does everything we need to do.
Yeah, just keep in mind this is a root process. So if you already have a problem, you already root, and you have access to it, you have access to everything. So basically, actually, root to access that.
Not that easy, really. I mean, it's incredible. You can get everything from that.
Yeah, just imagine like the process of TCP down because you're aware when you're listening to system calls. So
this is the same process. Actually, the founder was the guy who wrote Wireshark.
What if you get root and you do strace? You get everything. Yeah.
Yeah, exactly. Yeah.
But strace doesn't decode, and it's a blocking tool. So we do bunch of more stuff.
Last question there, I think.
I have a question. Yeah, like you showed here all the like SQL code. You guys decided to do something like passwords or anything, like hiding them away? Or
No,
anything?
we don't hide anything.
But you have the chance to disable the apps, so you can disable the
Exactly.
parsing of that. So you can, if you have security concerns where you have a policy where you don't want to see the SQL queries or HTTP, you can disable that. So
Exactly.
you don't show it.
So it's not being sent to the backend. At the same time, we offer on-prem deployment. So people who are thinking, oh, no, this in any case can leave my network. Okay, understood. Just let's deploy this in your cluster.
Cool. Thank you.
Last thing before I forget, we are hiring. So if anyone is interested in working for a very cool company, well paid, a lot of benefits, cool working environment, remote, just ping me on Twitter or on email, and I'll happy to give you more details. We are especially looking for a senior support for Europe. So if you are interested or you know someone, just let me know.